welcome to the last video for Class 5, and here we're going to be applying some of our Prolog knowledge to furthering our implementation of Wumpus World. The code we're looking at here is basically the code we had earlier. It's the propositional logic style where we have a predicate room of arity 2. The first term in that predicate is the room we're in, and the second predicate is a list of characteristics in the room. So we could define, I've defined 3 rooms. Presumably you can define 16 very easily, but this is all I need at least to demonstrate what I want to for today. So let's take a look at code that will help us figure out how to move around in the room. Now, here are some facts about our current state. So for instance, I've got one arrow, could be 0 if I fired it. I'm starting out in room 1-1, and my agent is facing north. Now, as the situation changes, like for instance we move from room to room, I'm going to retract this fact and assert another one with the new location of the room. And that's why I have these directives to the interpreter up here that tell the interpreter that the predicate arrows with arity 1, in room with arity 2, and so forth are dynamic. What that means is I'm telling the interpreter that these are predicates that I'm going to want to be able to retract and assert. If I don't put them there, they're going to be implemented in a way that's more efficient for Prolog, but doesn't enable us to assert and retract. So that's why those are there. And if you have predicates you're going to be asserting and retracting, you want to make sure you have this kind of directive to the interpreter for those predicates. Okay, so let's see how we're going to be able to move from room to room. Now, we can move in 4 directions, north, south, east, and west. And here's my predicate move for north. So we know we're facing north, so that's the direction our agent is going to move. And so I don't need to specify the direction in the predicate. So we'll instantiate the direction by calling facing, and now we know we're facing north. For the other directions, we'd have other versions of move with the different directions. We'll see what room we're in and instantiate x and y to the x and y coordinates respectively. Now we'll check to make sure that we haven't already reached the top row of rooms in the maze, because if we're in the top row of rooms, we can't move north anymore. So as long as the y coordinate is less than 4, we can still move north. So whatever that y coordinate was, which is 1, 2, or 3, our new y coordinate will be that old y plus 1. And I'm actually, so yn will be our new y. Then I'll retract the fact that we're in room xy, which was where we are now, and we'll assert z, which says basically assert this last, that we're going to be in room x and our new y coordinate. And that's all we need to do to move. So let's try it out. To begin, I'll load my little example. And let's see. Let's check that we're actually in the room we expect to be in. Yep, we're in xy. Our xy are 1 and 1. Yes, because they're all equal. Exactly. And let's see where we're facing. Direction. Well, we're facing north. All right, so here comes the acid test. Let's try to move. True. Okay, so let's see. Where are we now? Aha, we are in a different room. Now we're in room 1-2 instead of room 1-1, and things worked just exactly as we expected. And you can use these kinds of techniques to flesh out your own code for your own Wumpus world. I'll see you in class.